Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 4, Lesson 2, Solving Systems of Equations by Substitution. After this lesson, you'll be able to solve a system of equations using the substitution method. In the previous lesson, we used graphing to find the solution to the system, or the point of intersection, and today we're going to solve the system algebraically. In the model and discuss, we have Rochelle conducting an experiment, and she needs to create a solution, an 8% saline solution from these two. She has a 10% saline solution and a 5% saline solution. So similar to what we did in topic 1, where we had to combine different concentrations, we're going to write two different equations to figure out how much of each she will need. Part A, if she mixes the two solutions together to get 1,000 milliliters of an 8% saline solution. So these are the numbers. We're having a total volume and we have a total percentage concentration. So which one will she use more of? Well, if she's wanting 8%, 8% is closer to 10% than it is to 5%. So she's going to use more 10% solution and dilute it with a little bit of the 5% solution. For part B, how can we determine how many milliliters of each? Well, we're going to use two linear equations. Let's say that X represents the amount of the 10% solution, and let's say Y represents the amount of 5% solution. So that's just in milliliters. Okay, so milliliters, we're talking about the volume of each. So the total volume we know is 1,000. And to get the total volume, I'm going to add X and I'm going to add Y. Or I'm going to add the milliliters of solution A and the milliliters or volume of solution B. So there's our first equation. The next equation is going to be about the percentage. So remember in math, we're going to write percentage as a decimal. Okay, so 8% is 0.08. That's our total percentage concentration. And what's the percentage we're going to use for X? Well, it's 10% of X plus, so 10% times however many milliliters of solution A. And then solution B is 5%. So 5% times however many milliliters of solution B. We'll get our total of 8%. And that's our system of equations. We can solve this. So if we set them both equal to Y, then they'll both be equal to each other. And then we can solve. So I'm just going to show you how we can do that really quick. We're not going to solve it. We're just going to rearrange it. So we're going to move the X to the other side. That means Y equals 1,000 minus X. Okay, and here we need to do the same thing. We need to move the X to the other side and then divide by the coefficient. So we will have 0.05y equals negative 10.10x plus 0.08, and then divide everything by 0.05, and we would get our equation equal to y. And remember, if they're both equal to y, then they're equal to each other, so we can set them equal to each other and solve. We don't need to go through it all right now, but that's how we could do it. Example 1, solve systems of equations using substitution. So this is a great method if you have at least one of your equations in slope-intercept form. So here we go. We have an equation in our system that is in slope-intercept form, y equals mx plus b. So what this is saying is y equals all of this. Everything in the parentheses is what y equals. So it's helpful to put that in parentheses. Put whatever y equals in parentheses. Okay? So that's what y is. Y is 6x plus 7. That means this y in the second equation is going to be the same thing. We can substitute. Because if we're looking for the solution, we are looking where x and y are the same for both equations. So if they're both going to be the same, then I can just substitute 6x plus 7 into the second equation for y. So it's helpful, again, to put parentheses around that so you know you're writing whatever is in the parentheses, you're substituting into y for the second equation. So that's what we did here. We substituted 6x plus 7 in for y into that second equation, and then we're just going to solve. So we'll distribute, so we get 3x minus 48x minus 56 equals 4. And we'll combine our like terms, so we would get negative 45x. And let's add the 56 to the other side, so that would be 60. Divide both sides by negative 45. X equals negative 4/3. So we've solved for one variable. How do we solve for the other variable? Well, we plug in x into either equation. Let's plug it into the first one because that's easy to solve for y. So we're going to plug that value into the first equation. Instead of x, I'm going to substitute negative 4/3 and then add 7. That's negative 24 divided by 3 is negative 8 plus 7, y equals negative 1. So our solution then is going to be that ordered pair, negative 4/3, comma, negative 1. At that point, those two graphs would intersect. That is our solution. If I plug in x, if I plug in negative 4/3 to both equations, I will get negative 1. So after we did all the math, we can verify that it's true. We're going to check. So here we go. We're plugging in our value of y, which was negative 1, and substituting our value of x, which was negative 4/3. And if we do the math, we do get a true equation. And plug it into the second equation. Substitute our value for x and for y, and we do the math, we get a true equation. So that solution works for both equations. We have found the solution to that system. Let's try it using substitution. So again, whatever variable they're telling you, let's put it in parentheses. So this time, we don't have an equation in slope-intercept form, but we do know what x equals. X equals y plus 6. So I'm going to put y plus 6 in parentheses. That's what I'm going to substitute into my second equation for x. Make sure you're substituting into the correct variable. So I'm going to rewrite the second equation. Instead of x, I'm going to substitute y plus 6. If you want, keep it in parentheses so you know that's what you substituted. Plus another y equals 10. And then we just combine like terms. I get 2y plus 6 equals 10. Subtract 6 from both sides. 2y equals 4. Y equals 2. So we found the value for y. We found the y coordinate. How do we find the x coordinate? Well, we're going to plug that into the first equation. X equals 2 plus 6. X equals 8. So there's our solution, 8, 2 for part A. Let's do part B. I'll do it in a different color. So they showed us y equals all of that. So I'm going to put that in parentheses. That's what I'm going to substitute into my second equation for y. Make sure you substitute for the correct variable. So let's rewrite the second equation, substituting that value. So plus 3 times whatever is in the parentheses. That's what we're substituting, equals negative 7, and then we're just going to solve. We'll distribute first. So I get 6x minus 3 equals negative 7, combine like terms. I get 8x minus 3 equals negative 7. Add 3 to both sides. 8x equals negative 4. Divide both sides by the coefficient. X equals negative 1/2. We found our x coordinate. I'll write it here. How do we find the y coordinate? Well, we plug that in to one of the equations. Let's plug it into the first one to solve for y. Y equals 2 times whatever x is. We found it to be negative 1/2 minus 1. Y equals negative 1 minus 1. Y equals negative 2. So my y coordinate is negative 2. There's our solution. We're just solving algebraically by using substitution. Example 2. A vacation resort offers surfing lessons and parasailing. If Camilla takes one surfing lesson and then goes parasailing one time, she will pay a total of $175. So I am thinking of an equation for Camilla's lessons. On Friday, the resort collects a total of $3,101 for all the activities. So this is the total. And we can see during the week, 16 people go parasailing and 20 people take surfing lessons for the week. So I can be thinking of my second equation. How much does each activity cost? So first we need to define our variables. Let's say that x represents the price for surfing and y represents the price for one parasailing lesson. Okay, so let's think of Camilla. She does one surfing lesson and one parasailing lesson for a total of $175. So there's our first equation. For the week, we can see that 20 people went surfing, so that's 20x, plus 16 people parasailing, that's 16y, equals the total that the resort collected for the whole week. So we can solve by using substitution. Neither of our equations give us a value, but we can fix that easily. So let's solve for x. We're going to move the y to the other side. And when I do that, it gets the opposite sign. So x equals 175 minus y. That's what I'm going to substitute for x into my second equation. So you can see that's what we did. We substituted for x, 175 minus y. And then we distribute and we combine like terms and we get negative 4y equals negative 399. Divide both sides by negative 4. Divide both sides by negative 4. Here's our value for y. Remember, what does y equal? The cost of one parasailing lesson. So one parasailing lesson costs $99.75. Okay, we still need to find the cost of one surfing lesson. So how do we do that? We're going to plug in y probably into our first equation. So we can plug that into there. So let's just do it right here. X plus 99.75 equals 175. Subtract 99.75 from both sides. And x is going to equal $75.25. In order to check our answers using our graphing calculator, we would need to turn both equations into slope-intercept form. So the first one wouldn't be too difficult. We just move the x to the other side, so y equals 175 minus x. Okay, the other one might be a little trickier, so we need to move the x to the other side. That gives us, I'm going to do it down here, 16y equals negative 20y plus 3,101. And then we divide everything by 16. And we get y equals negative 5/4, sorry, this should be an x. X plus 193.8125. So we can plug those into our graphing calculator. So on our graphing calculator, go to y equals, pull up the y equals menu, type in our first equation, that was 175 minus x. The second equation would be negative 5/4. I'm going to put this in parentheses. X plus 193.8125. Okay, and then we'll graph it. We'll see what we get. I'm going to have to zoom. So we're going to need to change our window for this graph. Let's change, since our x value is just going up to 75, let's just go up to 100. So from negative 10 to 100, counting by 10. So change your x scale to 10. The y value, well, I know my y-intercept is just below 200, and that's all I really need to look at. So I'm going to put my maximum at 200 so we can see the y-intercept. And let's count by 20s. And that's how we get this graph. Now remember, to find the intersect, we're going to do the calc feature. So second, trace, go down and hit number 5 for intersect. Yes, that's on my first curve. Yes, that's on my second curve. Make a guess, move my cursor down to where it's approximate. And there is our intersection, 75.25, comma 99.75. That is what we got when we solved it algebraically. So to interpret the results, that means it would cost $75.25 to take a surfing lesson and $99.75 to go parasailing. Try it number 2. On Saturday, the vacation resort offers a discount on water sports. To take a surfing lesson and go parasailing only costs $130. That day, 25 people take surfing lessons and 30 people go parasailing for a total of $3,650. Okay, so we're going to set it up similarly with one lesson each. So X is our surfing, Y is our parasailing, and that only costs $130. Okay, and then we have 20 people taking surfing lessons, so 25x, and 30 people taking parasailing lessons. That was a total of 3,650. And we're going to solve using substitution. This time we're going to solve for y, since we did x last time, so let's move the x to the other side. We get y equals 130 minus x. Okay, put that in parentheses. So we know we're going to substitute that into our second equation. Whatever is in the parentheses, we're going to substitute for that value into the second equation. So 25x plus 30 times 130 minus x equals 3,650. And we will distribute 3,900 minus 30x equals 3,650. Combine like terms, get negative 5x plus 3,900 equals 3,650. We're going to subtract 3,900 from both sides. Negative 5x equals negative 250. Divide both sides by negative 5. X equals positive 50. So we found the value of one surfing lesson. One surfing lesson would cost $50. How do we find the value of a parasailing lesson? Well, we're just going to plug it into, we can plug it into this equation to find y. Y equals 130 minus x, which is 50. So y is going to equal $80. So $50 to go surfing and $80 to go parasailing on the weekends when they're offering their discount. Example 3, systems with infinite or no solutions. What is the solution to each system? So again, put parentheses around what you're going to substitute, okay? So we're going to substitute for y, whatever's in the parentheses gets substituted for y. That's what we have here. And we distribute. Negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. Combine like terms, so those 6x's cancel out. Negative 2 will always equal negative 2. That is always going to be a true statement. So this means there are infinite solutions. When you get a true statement or an identity, something that's always going to be true, then that is infinite solutions. Here's another equation. So this time we have y equals 5x minus 4. That's what we're substituting. Now be careful. We're substituting in front of a negative. So keep that negative. There's an invisible negative 1 there that we would distribute. So then multiply everything in the parentheses by negative 1. So we would get negative 5x and positive 4. 5x minus 5x cancels out. 4 does not equal negative 4. This will never be true. So if you get a statement that is never going to be true, there will be no solution. The opposite of an identity. Try it number 3. Let's solve using substitution. So y is going to substitute with negative x plus 5. So let's rewrite the first equation. X plus, I'm going to put it in parentheses, negative x plus 5 equals negative 4. Okay. Negative or positive x minus x, those will cancel out. 5 equals negative 4. Is this a true statement? It is not a true statement. So for part A, there are no solutions. Let's look at part B. I'm substituting for y this time. So I'm going to put it in parentheses so that I make sure I don't lose any signs. 2x plus 5 equals 5. Okay, 2x minus 2x, those cancel out. 5 equals 5 is an identity. It's always true, so there are infinite solutions. Example 4, using systems of equation to solve an application problem. Nate starts a lawn mowing business. In his business, he has expenses and revenue. Nate's expenses are the cost of the lawnmower and the gas. So we're going to have an expenses equation, and then we're going to have a revenue equation. We're looking for at what point his revenue exceeds his expenses. So before we can figure out when he starts making a profit, we need to find the break-even point. Where is the point where his costs or his expenses are the same as his revenue? Where are the two equations the same? That's the break-even point. So first we need to write the two equations. For his expenses, okay, y is the cost or the amount of money. X is going to represent the number of lawns he mows. We can see from the graphic, his gasoline costs $3 per lawn, so that's 3x. And his lawnmower is that one-time fee of $350, okay? You can see here, the initial expense was $200, and then it costs $2 per lawn to upkeep his lawnmower, probably making sure there's oil and things like that. For the revenue equation, y again is the amount of money, and we have that right here. He makes $40 per lawn. So here's our two equations. So again, the break-even point is where they're both equal to each other. If they're both equal to y, then they're equal to each other. So we're going to set them equal to each other. 3x plus 350 equals 40x, and then solve. Let's move the 3x over there. So then I would get 350 equals 37x. Divide both sides by 37. X is going to be approximately 9.5. If he mows 9.5 lawns, his revenue exactly pays for his expenses. So he can't mow half of a lawn. So if he mows 10 lawns, then he will start making a profit. Try it number 4. Fun Time Amusement Park charges $12.50 for student admission and then 75 cents per ride. Okay, so I'm probably going to have an equation for student admission. River's Edge Park charges $18.50 for student admission. So here's another equation at a different park, $18.50 plus 50 cents per ride. Okay, so we have our two equations that we can write. For what number of rides is the cost the same? So again, we're looking for the break-even point. Where are these two equations going to be equal? So if I'm defining my variables, x is going to be the number of rides, and y is going to be the cost, the amount of money. So for the first equation, the amount of money they spent, well, it's $12.50 to get into the park. That's your initial value, plus 75 cents per ride, or 0.75 times x. Our second equation, the cost is the entrance fee, $18.50, plus the cost per ride. So remember, per ride tells us we have a rate. We're going to be multiplying that by our variable x. And we're just going to set those two equations equal to each other and solve. So $12.50 plus 0.75x equals $18.50 plus 0.5x. Okay. I'm going to move the 0.5 to the left. That means I'm going to move the $12.50 to the right. So I'm going to subtract 0.5x from both sides. And then I'm going to subtract $12.50 from both sides. That'll cancel. 25.25x equals 6. And then divide both sides by 0.25. X is going to equal 24. So at 24 rides, the cost will be the same. Now, they didn't ask us for what the cost is, but we could solve for it. Just plug in x into either of the equations. Okay, so let's plug it into the second one to see how much money they would spend with 24 rides and what that cost would be where it's the same at both parks. 18.50 plus 0.5 times 24. Okay, so 18.50 plus 12. The cost that they're going to spend is $30.50 at both parks. We made it to the concept summary. We have solved by graphing, and now we learned how to use substitution. Okay, so remember to put your equations, at least one of them, into slope-intercept form or isolating one of the variables. So here they moved the y over. And then whatever is in parentheses, you're going to substitute in to the other equation for that variable. And then solve. And you'll get one variable, and then you plug that variable into another equation to solve for the other. Because remember, a solution has to be an x value and a y value. An ordered pair a point of intersection. If you have any questions, put them in the comments and make sure to come back for lesson 3.